list here. Not a really big deal. Would somebody get the participation ticket? Raise your hand and just tell me when you see that symbol and you're working a problem, what should you be thinking of? 3.14. You don't ever have to replace pi with 3.14. If it's a non-calculator problem, you just leave it in terms of pi. If it's a calculator problem, you just press pi on your keypad. But it is helpful to kind of remember it's about 3. This one is also helpful. So that's a special symbol just like pi is. And what's the numeric value you should be thinking of when you see that symbol? Dawson's, anybody else happen to know?
Natural log.
It's related to natural log because natural log means the log whose base is e. But e is actually just a number. It's irrational, like pi is irrational, meaning the decimals go on forever. You can kind of remember about its value, it helps. Related again, but not the same thing, no good comment. It's actually just a number. E is just a number. You're super close. 2.7 is good enough for our class. It's like 2.718. No. I actually don't know. I've only ever referred to it as E. I've had it like in many classes I took in college. We used it to do different computations. It's a naturally occurring. It just shows up in nature. I don't know the name of it, I'll be honest. There's probably some special name for it. Anybody else? I'm just lazy, so I just call it E. So memorize that. E is about 2.7. Related to that is this idea. Anytime you have 1 over any value, remember E is just 2.7, so it's just a number. But anytime you have 1 over a value raised to an exponent, like that, there's another way to write that without it being a fraction. If you don't remember, it's fine, but very. Yep, just e to the -2. We use that little identity quite a bit in this class, so that's important to remember. So this one, actually, let's do this. So e to the first is just e. So that means there's another way I can write this without it being a fraction as well. Someone else? Right? E to the -1. Any questions about that? Just get that memorized. We'll just kind of keep reminding you of it. Cool. Okay. Here's some powers of 2 that no one ever forgets, but it kind of does a good job of reminding us of something important. So somebody get the participation point quickly.
4.
That one's 4. Always like to throw out some nice, easy stuff for a while. Connor? 8. Nicely done. 2 to the 4th. It's so exciting. Let's do this for the next 20 minutes. Let's go Stephen Lenhoff.
16.
16. And I'm compelled now. I'm kind of locked in. I can't stop. To the 5th. Let's go. Hold on a second. Kate Robinson.
32.
Nicely done. We'll stop at 2 to the 6th because I'm too lazy to write a 3-digit number. At 2 to the 7th, so someone else like to get on the participation. Here we go, Brianne. 64, nicely done. Here's one that shows up on the AP test. A little bit less. Somebody else. Mary's in, anybody else know? Kate's in, somebody new hasn't got a ticket yet. Let's see who else. Anybody else? Remember? 1/2 power means something else. If you've forgotten, it's okay. Everyone forgets. David? Square root. Square root. So square root of 16 is?
4.
4. There we go. Perfect. Anybody else? Here's one. 27 to the 1/3 power. Somebody help with that. Rachel? 3. 1/3 power means cube root. So 27 third is 3. Question. just kind of random things that have shown up on AP questions over the years, so I'd rather just make sure you don't forget. Here's one. Forgot, it's okay. Mr. Recti likes to say the power is on high and the roots are below. That always brings back a fond memory for those who witnessed the Recti experience. Quite the thing. Wait, no, that one? Try to read it for you. Yeah, there you go. You can do it either way. You can do the root first or the power first. I choose whichever's easiest. So I would take the square root of 4, which is 2, and then I still have to do the cubing, so the result is 8. Questions from anyone? So when you have a fractional exponent, the number on top is the power, the number on bottom is the root. So the order is up to you. You can do it either way. So I said, well, finding the square root of 4 seems easier, so I'm going to do that first. So the square root of 4 is 2, but I still have to do the power. So then 2 cubed becomes 8. Good question. What else? Perfect. Okay, all of that leads to this idea. Okay, when I write log base 2, when I say the word log, it's just a quick, compact way of saying figure out the exponent. So, like the log base 2 of 64, all it means is if you take the number 2, raise the number 2 to some exponent, and end up with a result of 64, well, what was the exponent? 6. Log base 2 of 64 is 6. Please.
Can you review how to do that?
Uh-huh. So the reason I do this first, Keston, is because most people don't struggle with this. Like it goes really straightforward.
Yeah, I mean, I remember the logs, I just don't remember how to do them.
Don't even worry. Here's what helps the most, honestly.
Yeah.
Because when you see the word log for our class, like we don't do anything real complex with it. All you have to remember is log base 2, well, that means we've got 2 to some power. And the result is going to become 64.
Yeah.
So you're just kind of thinking backwards, and you're thinking, okay, 2 to the what is 64? Oh, it's 2 to the 6.
That makes sense.
So the log value is 6. That's all. No, good question. And don't, honestly, this is something I forget. I've been doing math for 35 years, and I still forget. It's just normal. So, yeah. Does that help? Good. Anybody else? So by the same reason, you could do this. Log base 2 of, say, 8. Somebody else, what's that going to be? Log base 2 of 8. Let's go, Chelsea. 3. Because we know that 2 raised to the 3rd power is 8. So, question. Okay, I showed you that. I've never, actually do one more. I've never actually seen a log base 2 problem on an AP test, but it helps us understand something that does show up on the AP test. So how about the log base 3 of 27, looking for a hand. Let's go, Jake Johnson. 3. 3 raised to the 3rd power is 27, so the log base 3 of 27 is 3. They need me to say it different, do a different example. Okay. Those kind of logs have never been on the AP test. I've studied every AP question pretty much that is publicly available since like about 1969, and they've never had those types of questions. But the type that does show up regularly is log base E. They don't write it as log base E, they abbreviate it, natural log. Log base E and natural log mean the same thing. But if you think of it like this, they become pretty easy problems. For example, if I write natural log of E alone, I'm asking the question. So natural log means log base E. That means e raised to some power ends up equaling e itself. So what's the power? Let's try that for a second. You got the right idea, you're just off by a little bit. So if I took e and raised it to the 10th power, that would be similar to taking 2.7 and raising it to the 10th power, which would be like 2.7 times 2.7, on and on and on. So that's not going to end up equaling just e itself. No worries. You're okay. So I want to figure out e raised to some power. It's like I was doing with Kesta up here. You know, this means 2 to some power ends up being 64. What's the power? The power is 6. This means, remember, ln of e means log base e of e. So I'm thinking of this e right here, and I'm thinking, okay, e to some number has to end up just being e itself, anyway, just 1. Because e to the first power is just e. Well, anything to the first power is itself. Does that make sense, Nate? Aaron, sorry.
Yeah, I totally agree with
Don't even worry. Happens to all of us. Anybody else? You would need to say it differently. Let's do another one. So if I write this one, now this looks kind of like the kind of question like, why would anybody ask this? It seems too obvious. If I write natural log of e squared, what I really mean is the log whose base is e of e squared. So I'm asking the question, if I take e, raise it to some exponent, and end up with e squared, well, what exponent must I have been using? 2. I take the log, natural log of, so if I say natural log of e cubed, somebody raise your hand please and tell me, this is asking e raised to some exponent, ends up being e cubed, just looking to give away a free ticket. What's the exponent? 3. Questions about what we mean by natural log. Here's one that's shown up on the AP test before. Natural log of 1 over e. Well, it's easier to deal with this if we use that little identity. So this is the same thing as the natural log of e to the negative 1. Somebody else would like to be in on the participation. This is saying e raised to some exponent ends up being e to the negative 1. Just negative 1. Okay, so that's really a very simple pattern. So, questions from anyone? Perfect. Related to all that is a formula you should memorize. The natural log of e raised to any exponent is just the exponent. So get that one memorized. The natural log, oops, the other way around, sorry. E raised to the natural log of some value is just the value. Questions? Perfect. Okay. Next thing. Last thing I need to have you have memorized reasonably well before we continue is you will hit AP problems once in a while that will require you to answer questions like this. And it won't be the end of the problem, it's just like while you're doing the problem, you'll have to come up with this answer. You'll have to do other things as well. They'll want to know what's the sine of, say, 5 pi over 6. Or they'll want to know what's the cosine of like 7 pi over 4. Those types of questions. You've all gone through the unit circle. I have my own method for memorizing the unit circle. I'll share with you my method. I'm a little bit prejudiced because I came up with it, but I think it's the easiest way to remember the unit circle. I don't memorize the whole circle. Like I can fill out a worksheet if you ask me to, but I don't memorize the whole circle. I think it's a waste of time. What I memorize are just some simple numbers. Here they are. 1, 2, 3. Can't really be any easier, just 1, 2, 3. All you do now is take the square root of each. So which is biggest? Just say it out loud. 1, 2, or 3? 3. Take the square root of each one. Just say it out loud. Which one is still the biggest? 3. Didn't change anything. This is still the smallest. This is still the biggest. Questions about that? Awesome. Now divide everything by 2. So just say top, middle, or bottom. Which one is largest? Just say it out loud. Bottom. 3 was the biggest. You take the square root of everything, doesn't change anything. Divide by 2 doesn't change anything. So your intuition is what you'd expect it to be. This is the largest value, this is the medium, this is the small. You okay with that? You add to the list a 0 right here and a 1 right here. You have everything you need to know, like numerically, about the unit circle. There's no other numbers that are involved in the unit circle other than these. Question. And once I have the numbers down, now I can worry about the angles. So if I'm supposed to find the sine of 5 pi over 6, again, I don't have it memorized. I just recreate it. So I just draw a quick circle. Put an axis. And then I just count. So I've got to get to 5 pi over 6. So let's see. Start right here. Here's 1/6, 2, 3, 4, 5. And then you need to do that again, do it differently, say it in a different way. So what's going to happen is you'll be working a calculus problem, and in the process of working the problem, suddenly it becomes necessary to know this. And I don't have it memorized. I don't want to memorize it. There's too many. So what I do instead is I say, okay, I just got to draw a circle, put an axis on it, and then I've got to count 5 pi 6. So I have memorized it to count the 6 that starts here, and this is 1/6. This would be 2/6. If we reduce that fraction, it becomes pi over 3. This would be 3/6. If I reduce that fraction, it becomes pi over 2. This one's 4, this one's 5. So that's how I count it. Does that help?
Yeah.
Anybody else? Once I've counted the angle, I look at my picture, I go from the center, and I simply move to the angle. So I go over a long distance, and I go up a short distance. The sine is always the up and down. The cosine is always the back and forth. So now I know that the sine of 5 pi over 6, that's the up and down. It's the short distance. The short one is this. We don't ever write root 1, so we just write it as 1/2. Because I went up, it's positive. The cosine of 5 pi over 6, I went this way. That's a negative direction. It's the long distance. So that's negative root 3 over 2. So that's my method of using the unit circle. I don't memorize the whole thing. I just kind of recreate what I need.
Can you do that last part again?
Uh-huh. So are you okay with like getting to the spot?
Yeah.
Perfect, no worries. At that point, you just start in the center. You're always going to go back and forth and up and down.
Yeah, so back and forth is cosine.
Mhm.
Yeah.
And sine is up and down. It's perfect,
Okay.
Justin. So I come over and I say, okay, wait a minute. So the cosine is going negatively.
Yeah.
And with the angles that are like sixths or thirds, it's always a long and a short. So one of the two is going to be long, one of the two is going to be short. They always alternate. So this is the long one, that's the cosine. I'm going in a negative direction. So that's why the cosine value turns out to be negative. Because it's the long one, it's the largest value.
Okay, okay.
But you just keep talking, you're doing great. When I get to the sine, it's the up and down. Like really, just keep talking. it's the short distance, so it's 1/2. Because I
Yeah.
went up, it's positive.
Yeah, yeah. Okay, so what defines it long and what defines it short?
Gotcha. Just visually.
Okay,
Like as you look at the picture, my circle's not perfect, but it's good enough to tell that if I start here and I only go back and forth and up and down, I have to go a lot further this way than I go this way.
yeah.
So this distance is much longer than this one. Does that make sense? There's only these choices.
Okay, yeah.
When you're dealing with the pi/6 and the pi/3, it's got to be either this one or this one. And so one of them, sine or cosine, is one of them, and then the other's the opposite. So because the back and forth was much more than this way, that's the one that counts as the cosine. It's the long distance.
Okay.
Let me do one more. Somebody get in on the participation. Just give me some angle that involves a third or a sixth. It doesn't really matter. Just make up something. Just some number. Keep it. 7/6. So if I'm trying to find, say, the cosine of 7 pi/6, I do the same thing again. Draw a circle, and I just count. So 1, 2, 3, 4, 5, 6, 7. Without even drawing anything, Kesta, if I'm trying to get from here to here,
Yeah.
by just going this way and this way, you tell me, is the back and forth or the up and down going to be longer?
Back and forth.
Back and forth.
Yeah.
So that means this is √3/2, because the cosine's the back and forth. And then did I go positive or negative to get to this spot?
Negative.
Negative, I'm done with that.
Okay.
Is that gonna help? Good question, Kessa. Just keep asking, really. Somebody else, please. Gotcha.
Okay.
So these two always show up if you're dealing with angles that are 6 or thirds. And they always just alternate back and forth. The middle one, Paris, only shows up when you're doing the pi/4, or multiples of pi/4. So for example, let me get a new page here. Somebody else get in on the participation. Just give me some 9/4. So Dawson says, what if we had to find, let's say, the sine of 9 pi/4? I do it the same way. I draw a circle. The fourth angles are always in the middle. So I just count again, Paris. Here's 1, 2, 3, 4, 5, 6, 7, 8, and 9 just keeps going. So this is 1 pi/4, but it's also 9 pi/4. They're the same angle. If I want to get to this spot, because the angle's right in the center of the arc, the distance over and the distance up and down are identical. There's no difference. So that's where the √2/2 comes in. So the cosine of that angle, 9 pi/4, is the value √2/2. And because I went up over in a positive direction, it stays positive. The sine has exactly the same value, √2/2. Because I went up, that counts positively as well. That makes sense, Paris?
Yeah.
Good work. Please.
So when we were like learning the unit circle, each quarter had like 3 different numbers, I felt like. So when does that come into play?
Gotcha. Yeah, what they taught you, which is not a bad way, I just have the way I like better, but they listed the angle first usually, and then they listed the back and forth distance and then the up and down distance. And that's usually the 3 numbers they're listing. Yeah. So I'm doing the same thing, I'm just doing it in a way that is easier for me to remember. That's all. So rather than list all those different numbers and build a whole circle, I just build it as I go. But it really is the same thing. The idea is that the back and forth distance is the x coordinate, and the cosine's values are always x coordinates on the circle. The up and down are y coordinates. So, do you want me to do another one? We'll have a quiz on this on Wednesday. Anything else? Another example? example, other questions, say it a different way, oh, please.
I had a question on the previous problem.
Uh-huh.
So why was the sine one 1/2 instead of square root of 1?
Oh, gotcha. So I did it this way because it makes it easier for me to remember the values, because they're all symmetrical. 1 over 2, 2 over 2, 3 over 2, square root, etc. But the square root of 1 is known. It's just 1. So that's why we read 1/2. It's technically not wrong. I'm not kidding. On the AP test, if it was a written portion and you wrote that, you'd still get full credit. On a multiple choice, they won't have this as an option. They'll just write 1/2. It's a great question. I think it's a great question because honestly, for like 30 years of my life, I never saw this pattern. Like I knew the numbers, but I never noticed that. Wait a minute. It's just root 1 over 2, root 2, root 3. So it's a good question. Anybody else? Quiz on Wednesday about this kind of stuff. So, oh, please. Uh-huh. So somebody just give me some angle. It doesn't really matter what it is. Just let's go, Ethan. 11 pi over 6. So if I'm asked to find the cosine of 11 pi over 6, I draw the circle, put an axis on it, and again, I honestly just count it, because if I don't count, I'll make a mistake. Like I'll picture the wrong spot. And so I just say, and I don't, like I was saying to Dawson, I don't fill in all the ones in between because I don't need them. So I just, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, you tell me here, get to the spot, which is larger, the going over or the up and down? Going over. The cosine is the back and forth. So it's the large one, root 3 over 2. When you went over to get to this spot, Eric, did you go over the positive or negative? From the middle. What was that? You were sine, Erica? You guys can go. Good job. The sine's up and down.
Wow, that makes I was kind of. I'm just kind of.
Root 3 over 2, and the opposite
See if I get like
would be because they always alternate.
Like a jazz class, but so it's like I don't feel
Correct.
like.
Because she'll
Dylan Anderson, will you come to the attendance office? Dylan Anderson, please come to the attendance
These
office.
always
Thank you.
involve the 1/2 and the root 3 over 2. And the sine and cosine are always one of them, and others the opposite.
Or maybe Morgan, maybe
If
we get
it's
involved.
this type of angle, it's always this value.
Maybe Morgan. Yeah, maybe Amy
And
will
the
teach
over-
Ron dance as much, and
Just
maybe we have more
sometimes
time
both
for
positives,
teach.
sometimes
Or
both
I'd
negatives,
really,
sometimes
or I'd
both-
rather take a class with like little kids and literally do like
that's what
gigs
we
for
have
different
here.
colors.
Yeah, there are other angles, but no one
So
is-
I'm just gonna kind of see what happens.
So the purpose of the circle
It
is just
should
to
be
make it
awesome.
easier to memorize the ones they expect.
And I get a little annoying getting them.
Cosine is this
Back
way
and forth.
and sine's up.
Sine is up and down.
It's this way.
to get lunch. Very good. I just didn't get quite that far. Perfect, because you went down. And this is kind of a dumb memory thing, but the up and down, I just look at the eye and all that's up and down.
Okay.
So it reminds me of the size.
No, that was.
Maybe. I don't want to do
Thank you.
Stop by your shirt.
I understood the part about.
Good job, you
down
guys.
low around and then deciding to fit longer or shorter. I'm just confused about the values, so I was just confused.
Oh, yeah, no worries. So stop by Letitia here.
I have an issue with calculators, so I have a two-egg spider, and the spider doesn't have the CAS spider you can get on your
There, okay.
red one, or will that work for this case?
Because I think it'll actually work. I'm not positive. Bring it in and we'll try it. You got it because AZT doesn't allow you to add. I said, because like the TAE4, which is used for calculus, doesn't have an algebraic system either. And it does everything we need on the test. The algebraic system, in fact, my belief is they write the questions in such a way that having that doesn't help. So I think you'll be okay. But bring it in once you want that. Definitely.
I just had a question. When it says like 11 questions, can you just say that you guys just count
Sure,
questions
go
and
back.
then go down?
Oh, yeah, absolutely. Nicely done, Mary. Good work. See ya. So you play soccer, right?
I used to.
Oh, you don't play anymore?
No, I don't.
No worries. Everybody ends at some point.
Yeah,
So,
sure.
it's normal. So, I just remember your name from years. Like I said, it's a family thing, right? When I know somebody else, I hear their name, like, oh, I bet that's their sister. That's
Yeah.